In this video series, I will go over some of the things that I have learned in my 30 years in printing, 25 of those were years working in an implant environment, and in my decade-long journey in managing for quality. The concepts and tools discussed in these video series is a accumulation of my experience managing an implant and as a certified Lean Six Sigma, black belt, and a G7 professional. I sure hope these short videos will spark a conversation or inspire you to start your own journey into managing for quality. Historically, printing firms have focused on controlling color output on their printing devices by measuring the density of the ink or by measuring color in a defined color space like CIE, L star, A star, B star. Offset, inkjet, and toner-based print processes are pretty well covered in process control certification systems like ISO and G7 that define color space specifications. Other print processes, such as bindery and mail sorting, also have automated or manual quality control systems. What we do not have is an effective way to measure process control or for quality control measures and all the other parts of providing print products and services. Other processes in our implant process, like post-press, specialty printing, online engagement, customer service, returned mailings, all require ways to ensure that what was being performed is number one, consistent, and number two, meets the needs of the customer. These processes in graphic communication can and also should be measured to determine if they are meeting the needs of the customer. Most quality control measures have two things in common. They attempt to achieve process stability and process capability. Two different components of quality control. Both have to be achieved and maintained in order to ensure quality control. Process stability is the first step. Without it, we cannot move on to the next step of process capability. Process stability is the ability of the process to produce consistent results, which is determined by measuring the process using statistical data. The ability to produce something exactly the same at different times of the day with different operators or even at different locations is a fundamental step in managing for quality. Think about a McDonald's sausage McMuffin or a Big Mac. McDonald's franchise system ensures that no matter wherever you go, you will most likely get the same product every time at every McDonald's you visit. Process stability is measured with an allowed tolerance of the standard deviation of the process. An example, plus or minus 3 standard deviations from the average of the process, which are called control limits. If the sample or data points exceed the control limits or follow patterns that are not predictably random, then the process is deemed to be unstable and cannot be trusted to move on to the next step of the quality control process of capability. An unstable or unpredictable process will have abnormal or special cause variation from an unknown cause that is making the process unstable. If a process is unstable, then it cannot produce quality. We must first bring the process to stability. This is referred to the voice of the process, or the VOP, or what the process is trying to tell us in terms of what type of a variation is occurring. The process stability is determined by measuring the variation of the process via a run chart that has the 3 standard deviations plotted as the control limits. If the process does not go past those control limits or follow some type of pattern, then the process is deemed to be stable or predictably consistent. Process capability, the second part, is the ability of the process to hit customer requirements, which is determined by measuring or counting data of the process and using mathematical indexes to determine if the process is capable of hitting customer specifications. Process capability determines if a process is producing quality products or services. And when managing for quality, the customer determines what is acceptable or not. Thus, the customer defines what quality is. To put a definition of what is quality, quality is often referred to as being in conformance or non-conformance to the needs of the customer. Conformance means you are hitting the customer's specifications. Non-conformance means you are not. At print processes, you use colorimetric or densities to determine if a color output matches industry standards. An example, the Pantone matching system, SWAP, G7, etc. are covered in the capability analysis. As long as we can measure and record data in a process, we can define targets that, as long as we maintain, along with allowable tolerances, we can ensure we are producing quality products in whatever process is being measured. For instance, to ensure a quality face trimming, the customer requested 11-inch dimension on their annual report. And as long as we do not deviate no more than 3/10 of an inch or 1/32 in either direction on the 11-inch, we are meeting the customer's demand. Why do we need both? We can be consistently good or consistently bad. Once we determine if we're consistent and predictable, then we can move on to the next step to determine if we can meet the customer's needs in the form of specifications. For quality control measures, we need to meet both requirements of stability and capability. For instance, say you're interested in purchasing a Tesla Model sedan. A selling point for you is the specification of its being able to go from 0 to 60 in 1.9 seconds. However, when you test drove the car, it pulled aggressively so much that you could not drive past 30 miles per hour. In order to meet your need, the car has to be stable enough to drive straight, or it can be tested to go from 0 to 60. That is why we both need stability and capability in our quality control methodologies. In the upcoming videos, we'll examine the steps in how to create a quality control methodology for your non-printing processes, specifically in your in-plant environment. Please feel free to contact me if you have any questions or comments.